Ladies and gentlemen, welcome to the Honda stand. My name's Natasha and I'm very happy to be here with you today. As you know, Honda designs and develops a whole range of different things. Bikes, cars, solar panels, jets and even robots. And what do all of these things have in common? They're all the result of the hard work, the engineers and scientists at Honda. And without them, the world we live in today would be a very different place. At Honda, we believe in the power of dreams and the ability of our engineers to change your dreams into reality. In a moment, I'm going to show you a film that shows you exactly how Honda conceptualized and developed something that most people thought of as impossible. I'm talking, of course, about the famous robot Asimo. A walking robot that will one day be so advanced it can really help people. Enjoy the show.
Asimo, one of the world's most advanced humanoid robots. In many ways, Honda can best be defined by its pioneering research and development in advanced humanoid robotics. It requires state-of-the-art technology, a spirit of innovation, a dedication to enhancing people's day-to-day lives by expanding mobility, and a focus on serving customers and creating products that benefit society. In a world designed for humans, engineers first focused on developing legs that could walk independently. In 1986, Honda's first experimental humanoid robot, E0, took its first successful steps, but it was too early to say that the robot was truly walking. E0 took about 5 seconds to complete each step, and it could only walk in a straight line. Known as static walking, this is different to the way humans walk. So Honda's engineers looked closely at how people walked and maintained balance to better understand the mechanisms of movement. How do knees move when people walk? How much force does each joint receive? What is the average walking speed? In their study, they found that when humans walk, they get just off balance, as if they were about to fall forward. This walking while falling is very difficult to simulate in a robot, and it was a challenge in which no one had ever succeeded. In 1988, a key milestone was reached in the E2 experimental robot by successfully imitating a human's dynamic walk. E2 could walk at a pace of 1.2 kilometers per hour on flat surfaces, and successive robots in the E-series made additional progress. However, all E-series robots lacked a torso. But with control of leg movements firmly established, engineers were able to move on to the next major challenge, creating a complete robot with a body as lightweight and efficient as possible. Research and development also expanded to refine the movements of the robot's arms and hands. These efforts led to the introduction of P1, Honda's first prototype humanoid robot, in 1993. Standing 191 centimeters and weighing 175 kilograms, it had a rugged appearance. But at last, a humanoid robot had been created. In 1996, engineers achieved a number of major breakthroughs in its second prototype humanoid robot, P2. Improved stabilization control technology provided more flexible leg movement. P2 could walk smoothly in any direction, walk over uneven surfaces and bumps, and even maintain its balance when standing still or when firmly pushed. And by wireless remote control, it could complete simple tasks like pushing a trolley or tightening and loosening bolts. Standing 182 centimeters and weighing 210 kilograms, P2 now also housed all necessary operating devices. 9 months later, in 1997, an all-new prototype robot, P3, was introduced as the first completely independent bipedal humanoid walking robot. P3 stood at 160 centimeters and weighed 130 kilograms. It could walk at a faster pace of about 1.9 kilometers per hour with superb balance and fluid motion. Its onboard brains now had the processing power of 30 personal computers. The next stage of the dream challenged engineers to create something that could function in an actual human living environment to better enable it to help people. The result was Asimo, an acronym for Advanced Step in Innovative Mobility. When first introduced in November of 2000, Asimo stood at 120 centimeters and weighed 52 kilograms. Compared to its predecessors, Asimo achieved better balance, was more nimble on its feet, even more stylish in its design, and was capable of simple operations within a human living environment. In Asimo's walking abilities, engineers again broke new ground. Where earlier robots had to stop to make turns, Asimo had an unprecedented ability to walk and turn smoothly with Honda's intelligent, real-time flexible walking technology. Asimo could now predict its next movement and adjust its center of gravity accordingly. In addition to climbing and descending stairs, Asimo could also maintain its balance automatically without any preset walking patterns. This made it possible for Asimo to negotiate slopes or even balance on one leg. Asimo's height was also an important strategic decision. Its size allows it to easily operate in our own environment, and its eyes are located at the same height as those of a seated adult. Since its introduction, Asimo has been equipped with voice and visual recognition technologies, which allow for even better interaction with people. Asimo continues to be refined and improved, moving it ever closer to the dream of developing a robot so advanced it can really help people. Much work still remains, but with Asimo, Honda has truly taken an advanced step in innovative mobility.
Right, now you've seen the story behind Asimo, but Honda has continued to develop its robotic program, and today we have the pleasure of welcoming the second version of Asimo. Are you ready to welcome Asimo?
Yes.
Asimo, I think the people are waiting for you. Ladies and gentlemen, Asimo. Asimo, hello and welcome.
Hello, Natasha. It is great to be here in Dubai, and I'm really happy to meet so many new friends.
We're all very happy to meet you as well. Now, to illustrate the great progress Asimo has made towards greater autonomy, let's do some daily life tasks. First of all, let's imagine this stage is my apartment, a place where a humanoid robot like Asimo would be most useful. I've just had some friends over, and I would like Asimo to bring us some drinks. Now, to do this, all I need is my PDA. I'm going to order 2 teas and an orange juice. And Asimo already knows the location of the drinks because it's been pre-programmed. All I need to do is press enter.
I'm going to the bar.
Now Asimo needs to locate the waiter. You'll notice that he's wearing a badge Asimo can read with its infrared sensors.
Mr. Barman, I'm here to receive orange juice and 2 tea for Mrs. Natasha. I'm receiving drink for Mrs. Natasha.
This is what we call the intelligent walking system. But what is an intelligent walking system? It basically means Asimo is able to predict its next move and thereby change its center of gravity accordingly, very similar to the way you ride a walk. It can also change direction without stopping and modify its speed and length of its stride. Asimo, could you show us walking, please? Please notice the different strides Asimo's doing. Some are long while others are quite short. Very good, thank you. Now, Asimo can not only walk because the engineers at Honda decided to push this technology to the limit. So they gave Asimo the option to run. The difference is, when Asimo is running, for a very small fraction of a second, both of Asimo's feet are off the ground. Can you show us your running, please, Asimo? Very, very wise, Asimo. It's always good to warm up before we do any kind of strenuous physical activity. Very good. Whenever you're ready, Asimo. I think that deserves a clap. Now this was Asimo running in a straight line. However, Asimo is also capable of running whilst turning. The difference is Asimo runs at 6 kilometers per hour in a straight line and 4 kilometers an hour if it's turning. Asimo, can you show us your running whilst turning, please? Very good, thank you. Now some people might ask, what's the use of having a running robot? And we can summarise the answer to this in one word, and that is safety. If you have a running robot, then it means the robot can keep its balance while it's doing quick movements, which makes it more agile and it makes it easier for the robot to react. So if something crosses its path, then it's able to stop. And this is what we're going to demonstrate next. I'm going to ask Asimo to walk to the stairs, but I'm going to stand in its path. Asimo, can you walk to the stairs, please?
I stopped because my route was blocked.
Okay, as you can see, it's only after I move out of its way that Asimo continues on its route. Now let's not forget, we're still in my apartment, and for the robot to be truly useful in a space such as this, it needs to know how to climb up and down stairs. Now this is not something we usually think about too much, but how many different measurements and calculations does our brain need to make to let us do this? And how many different muscles do we need to use as well? A very interesting case in point is with toddlers. Those who have learnt to walk can still only crawl upstairs. هلا رح نطلب من أسيمو يطلع الدرج. إشي ما بنفكر فيه كتير، بس كم حساب لازم نعمله قبل ما نطلع الدرج، وكم عضلة نستعمل لما نطلع الدرج. هلا مثال كتير كويس للولاد الصغار اللي بلشوا يمشوا لسه بيضطروا يحكوا لما بيطلعوا الدرج. Asimo, would you climb these stairs, please? Very good, thank you. Excuse me, come on. Now let's remember the video we watched at the beginning of the show, how difficult it was for us to simply get the robot to walk without falling over. We now have a robot that can walk, run whilst turning, and climb up and down stairs. Asimo, could you walk down your stairs, please? It's not because Asimo is dizzy. Asimo is simply recalculating its position so it can walk down the stairs safely. هلا Asimo مش دايخ، عم بيعيد حساباته عشان يقدر ينزل الدرج بطريقة آمنة، وهذا اللي عم بيعمله هلا. Asimo, are you ready now? After you. Very good, thank you very much. Come on, a round of applause, guys, come on. Now, Asimo and I are going to get a little bit emotional, which is easy to do when you're working with something that resembles humans so closely. Asimo and I are going to shake hands.
Let's shake hands.
Let's shake hands indeed. Please notice the very delicate hand and finger movements. Also notice the way Asimo tracks me with its head. As I move my head, Asimo also moves its head. I'm going to push Asimo, listen to what it says.
Whoops.
Asimo can keep its balance by itself. I'm also going to pull Asimo. Listen again.
Whoops.
Thank you, Asimo.
Thank you very much.
Thank you very much. Now I think Asimo deserves a little break. So how about a spot of soccer? I'm going to take this ball and place it in front of Asimo. However, to make things a little more difficult, I place the ball in front of Asimo's right leg, but we want Asimo to kick the ball with its left leg. So first it's going to locate the ball with its sensors and then reposition itself. هلا أنا وأسيمو راح نلعب كرة. أنا حطيت الطابة قدام رجله اليمين بس بدي إياه يضربها برجله الشمال. أسيمو راح يلاقي الكرة وراح يضبط الموقع تبعه عشان يقدر يضرب الكرة برجله الشمال. Asimo, I'm ready whenever you are. Very good. I don't think you're ready for the professional league just yet. No, don't be angry. I still think you're very highly technologically advanced. Now, we're going to get a little bit technical. You've seen Asimo moving from the very beginning of the show, and this is called the degree of freedom, or DOF. Asimo has got 34 DOFs. Let's take its head for example. It can move it laterally, vertically, and it can lean on one side. Now for each of these movements, Asimo needs a small electric motor, which means there are 3 electric motors in its head alone. So can you imagine the kind of movement 34 different motors working together can achieve? And what better way to show you this than through dance? Let's have some music, please. Amazing. Thank you, Asimo. Thank you.
Thank you.
Thank
I want to dance some more.
You do? Okay then. Very good. Thank you very much. You proved that engineering and science can be very fun as well. Now, it's easy to forget that Asimo is not a real person. However, Asimo is not science fiction, nor is it a computer-generated robot you're watching in a movie or on a video game. Asimo is science fact, and the result of the hard work and dedication of the engineers and scientists at Honda. And that's what makes Honda so unique. And that is the power of dreams. Asimo and I are going to say farewell now. Thank you very much. Thank you, Asimo.
It is a pleasure being invited here. Goodbye, everybody. Hope to see you soon.
Goodbye, everybody, and thank you.
जो इंटेल के थे वो कैसे थे हैं?